Okay, so I have had a special request to make a video for some of the problems on the first 7.2 highlighted / starred assignments. I will make as many videos as I need to get through these. So here we go. Alright, number 9, and again this is on the assignment number 1, which was the highlighted, and this one I am not taking up, but you still need to know how to do these skills. Okay, tangent, and again, there's not just one way to do these, alright? Okay, it depends on what speaks to you and what makes sense to you. Alright, they're asking us to find the exact value. Okay, well the first thing you're going to notice is I don't have any clue where 19 pi over 12 would be. I'm not familiar with that, and it's not a common angle to me. So I need to break him out into two angles that do make sense. In other words, two angles where I can retrieve the sine, the cosine, or the tangent value from the unit circle. So what I decided to do, I decided I would break this into 10 pi over 12 plus 9 pi over 12. You may do 16 pi over 12 plus 3 pi over 12. Okay, same thing. You're going to get the same answer. All right, so this is going to be my alpha, this is my beta, but here's the cool thing. These are going to reduce down to recognizable betas. This is going to reduce to 5 pi over 6, okay, and this is going to reduce to 3 pi over 4. All right, well, why is that important? Because those are our guys on the unit circle. Okay, so those are the ones that we're going to use, and we can pull the tangent value from them. All right, so we're going to use tangent, so I'm going to use the tangent of alpha plus beta, and I'm doing a plus because I'm adding them together. So I'm going to say tangent is now going to be 5 pi over 6 plus 3 pi over 4. Okay, so there's my alpha and my beta. Alright, so we go to our formula sheet for the, I don't have it in front of me, but you've got your formula sheet. So I'm going to go ahead and I'm going to work this out. So we're going to say the tangent of 5 pi over 6, right? I'm just going to put it in the tangent identity form. Tangent of 5 pi over 6 plus the tangent of 3 pi over 4 over 1 minus the tangent of those two, okay, 5 pi over 6 times tangent 3 pi over 4. Okay, so these are our recognizable angles. So now I'm just going to substitute the values in for tangent at that location. Now remember, you have to watch the SIGNS. Exclamation point, because according to a smart trig class, tangent's only positive in third quadrant. Okay, so when we're assigning tangent values, we've got to make sure we give the right SIGN. And I'm saying that because SIN and SIGN sound phonetically the same, so I wanted to distinguish. Okay, so if I'm going to look at 5 pi over 6, 5 pi over 6 is absolutely on the unit circle. It is going to be in quadrant 4, okay? And we know that 3 pi over 4 is also on the unit circle, and 3 pi over 4 is going to be found in quadrant 2. All right, well that's important because if we have one in quadrant 4 and one in quadrant 2, then we know those those tangent values should be negative when we set this up. Okay, so the tangent of 5 pi over 6, well this is a 6 family member, and tangents, it's all of pi over 6 family members have a radical 3 over 3, and then we have to decide positive or negative. Well, this is in quadrant 4, where tangent is negative, because the only thing positive is cosine, so it's going to be negative radical 3 over 3, okay, plus the tangent of 3 pi over 4. Well, 3 pi over 4 is a pi over 4 family member whose tangents are always either 1 or negative 1. Well, if the tangent I'm looking for is 3 pi over 4, that's going to be in the second quadrant, therefore tangent's going to be negative. So I'm going to put that there. Okay, now we have downstairs 1 minus, okay, the product. Well, we know that we've already found our values. Tangent of 5 pi over 6 is negative radical 3 over 3 times tangent of 3 pi over 4, which we know to be negative 1. All right, so I'm going to move to the next page, okay, because I'm running out of room, and we're going to finish this out. Okay, whoops. Okay, so continued. Number 9 is continued. Okay, so we are looking at negative radical 3 over 3 minus 1 upstairs over 1 minus the multiplication of negative radical 3 over 3 times negative 1 is positive radical 3 over 3. Okay, I'm just simplifying from the prior step. Okay, now we can simplify more. Now you probably could skip this step, but I'm going to do it because a lot of people go, wait, what did you do there? Alright, so negative radical 3 over 3 minus 3 over 3, because that's equivalent to 1, over 3 over 3 minus radical 3 over 3, because this 1 is the same as 3 over 3. Okay, so that's going to give me, upstairs, I'm going to have negative radical 3 minus 3 over 3, ow, sorry, just got a paper cut, over 3 minus radical 3 over 3. Okay, so we have a complex fraction. Okay, so what we're going to want to do next is we're going to want to get rid of that 3 in the denominator, right? So to get rid of the 3 in the denominator, we're going to multiply the top and the bottom, okay, by what we're trying to eliminate. So that will cancel and that will cancel. Okay, now we are left with negative 3 plus radical 3. Wait, I missed something. That's negative. That's the negative. That was my bad. Okay, so this should be minus, I like my radical in the back end. So negative 3 minus radical 3 upstairs. And then downstairs, okay, we're going to have 3 minus radical 3. Alright, so we have binomials. And now we have downstairs, we are going to have to multiply by the conjugates. Okay, so conjugates to, the conjugate to this. So that's going to be 3 plus radical 3 and 3 plus radical 3. Alright, now we're ready to FOIL upstairs and we're ready to work our perfect difference of squares outcome downstairs, which is the result of multiplying conjugates. Alright, so we're going to FOIL upstairs and we're going to have the result of a squared minus b squared, right, which is a perfect difference of squares downstairs. So I'm going to go to the next page, and you know I write big, so I'm having to continue this over. Alright, so number 9. Still going at number 9. Okay, so let me rewrite where we were. Negative 3 minus radical 3 over 3 minus radical 3. And we're going to multiply that by the conjugate, right? And the conjugate we determined was, the conjugate to this is 3 plus radical 3. So you're going to FOIL this. And this is going to end up being a squared minus b squared, okay? So if we FOIL the upstairs, we're going to have negative 3 times 3, that's negative 9. Outer times outer is minus 3 radical 3. Inner times inner is minus 3 radical 3. And last times last is negative times positive, which is a negative, and that's going to be radical 3. Is times itself just gives me 3. Downstairs, we're going to have 3 squared minus radical 3 squared. So the perfect difference of squares there. All right, let's keep trucking. Okay, so in this case, upstairs, it looks like we have negative 12 minus 6 radical 3 over 9 minus 3. So that's going to be negative 12 minus 6 radical 3. That's going to be over positive 6. And then we are simply going to simplify this. I'm running out of room on my table. Sorry, folks. Okay. That's going to give us negative 2, and that's going to give us just minus 1. So the final answer is negative 2 minus square root of 3. Okay, so that's taking an unknown wonky angle and turning it into something we can work with. And it's using sum and difference. Okay, sine, cosine, tangent. All right, so that's that guy. Let's see what we have on next on the list for this particular video. And I'll see how much time I have. I gotta watch my time. Okay, and I have to stay definitely under 15 minutes or YouTube will reject my video, and that would not do well for any of us since we need these videos. Okay, number 27 was the next one requested. let me take a look and see what number 27 entails. I can pause this. All right, we're back. Okay, I don't like number 27. I think they threw this in here, and I don't even think, I mean, it doesn't even make sense to me. So, I mean, it does, but I don't like it. I'm just not sure why they approach it this way. What they did is they took, because remember this, the reciprocal for, like, let me just, okay, so the sine of, say, 30 degrees is equal to the complement to this, right? So it's equal to cosine of 90 minus 30, okay? So that's what they did here. They just look at the cofunction identity, because these are complements, right? All right, because this would leave you with 60 degrees, all right? Now, what they did is they did it in radians, and they put tangent and cotangent together. And it's kind of strange what they did, but I'm not going to give you one like this because I don't think it makes any sense, actually, the way they did it. But I'm just going to explain what the, so they're going to say, okay, the tangent of theta is equal to the cotangent of pi over 2, which is 90 degrees, minus theta. Okay, this is their preface. So they're going to say, okay, the tangent that they're giving us of pi over 3 plus x is equivalent to cotangent of 90 degrees, which is pi over 2, minus theta. Well, the theta they gave us is pi over 3 plus x. Okay, so then what we have here is we have, ends up being simplifying to the cotangent of pi over 6 minus x, because obviously we're going to distribute the negative, and that was their answer. I'm not a fan of this problem, so I don't want you to worry about seeing it. It's just the cofunctions and the complement situation. They did it on a couple of them, and I'm not quite sure why they chose this method and how we will write it in terms of cotangent, because we don't even have a formula for cotangent. It's actually would have to be 1 over tangent values. So, you know what, let this one go. Boo. Okay, so you won't have that one. All right, let's see what's next on the list. If it's another wonky one, we're going to blow by it too. Let's see. 32. Okay, I think I'm going to pause here and I'm going to end this video because I don't want it to run over time, and I'll make video number 2. Okay, see you on the flip side.